All right, so let's go over the review questions that you were supposed to do. So the answers are, sorry, my eye was itching here. Number 2, the first one, remember all the terms, those you should be familiar with. As we go through this, those terms will be coming out in the different explanations. So number 2, explain how machines make work easier. What it does is it lowers the force that has to be applied. So, and if you remember, I'm going to draw this up here again, but because we'll reference it a bunch of times, is remember that mountain and the whole idea that we can either climb straight up the mountain or we can zigzag up the mountain to get to the top. Which way is more work? Is it zigzagging or straight up? Well, reality is it's the same amount of work either way. But which one takes less force? Well, this one is less force going this way. It just, takes you longer because you have a longer distance to travel. And that's actually what simple machines do is they're like taking the zigzag thing, so it takes less force, but you have to go a longer distance. Question number 3, what does the equation W in equals W out mean? Well, that's work in equals work out. So whatever work you put in, that's the work you're going to get back out of the machine. So kind of like in this one, if I were to calculate the work going this way up and I were to calculate the work going this way, they would turn out to be exactly the same on that climbing that hill. Same idea if I'm taking a hammer and I'm trying to pull out a nail. Well, there's an amount of work that I do up here, a force over a distance that I pull on it. Then down here, I also get a force over a distance in order to pull that nail out using the hammer. So, and those two works are equal to each other, work in and work out. Question number 4, calculate the mechanical advantage if a man applies an effort force of 20 newtons to pry open a sewer drain cover that has a resistance of 600 newtons. So what you're going to do is you're going to take the resistance divided by the effort. So 600 divided by 20. If you did that mathematically, you'd find out that it is 30. So that's 30 to 1. There's no units for mechanical advantage. It's just to 1, which what that means is if you put 1 pound of force into this, you're going to get 30 out. All right, so you're multiplying your force like crazy in this device. So, question number 5, a machine that only changes the direction of a force has a mechanical advantage of 1. That's all. This would be like having a pulley on the curtains in the back of the room. I can pull the rope down, and as I pull the rope down, it slides the curtains across. So it changes the direction of my force. It makes it so I can stand in one place and move those curtains a long distance back and across the windows in my room. Number 6, machine with a mechanical advantage of more than 1 is used for what? Oh, that's used to multiply force. It raises my force and makes it so that I can pull a nail out of a board with this hammer, versus if I were to try and pull it out by hand, I'm not going to be able to do that. The second half to number 6, a machine with a mechanical advantage of less than 1 is used to do what? That's used to multiply speed. That would be kind of like the high gears in your car, right? Those are have a mechanical advantage of less than 1 to make it so that you can go really, really fast. But it's also you lose a lot in force. So that's why you can't start in 4th gear in a car, because your car doesn't have enough force to try and start in 4th gear. It would be too hard for it to do it. Number 7, classify the 6 simple machines as either levers or inclined planes or modifications of these. So levers, well, levers, one would be a lever, a second one would be a wheel and axle, and a third one would be a pulley. All 3 of those, lever, wheel and axle, and pulleys, they're all levers or a modification of a lever in some way. Inclined planes, well, an inclined plane is one, obviously. A wedge, like we use to hold the doors open at school, and a screw. All 3 of those are inclined planes or a modification of an inclined plane. Number 8, what is a block and tackle? Well, block and tackle is where you have a pulley at the top. Let me show you one here. Second. This is a block and tackle. Turn this around. Yeah, I'm trying to do it. There we go. All right. So on this thing, what I have is I have a pulley at the top with a rope that comes down. All right, and that will pull up another set of pulleys down below. And what it does is it makes it so that I can lift something that's really, really heavy and not have to use very much force. Now in doing this, how do I determine mechanical advantage? I count the number of ropes that are present. So in this one I have 1, 2, 3, 4 ropes between the two pulleys. So this thing has a mechanical advantage of 4 to 1. So again, what does that mean then? It means if I want to lift something that weighs 100 pounds, and I only have to put 25 pounds worth of force into it in order to lift it. I can lift something 100 pounds by just pulling with 25 pounds of force. But because it's a 4 to 1 ratio, I got to pull 4 times as much rope to lift it a short distance. If I want to lift it 1 foot, then I have to pull 4 feet of rope is what happens. So going back to this idea. All right. And number 9, calculate the mechanical advantage of the following. A wheelbarrow that has 2 meters to the load of bricks and 6 meters to the handles. So in that, we're going to take 6 meters divided by 2. That gives me a mechanical advantage of 3. And then a wheelbarrow that has 2 meters to the load of bricks and 4 meters to the handles. So that's 4 divided by 2. That gives me a mechanical advantage of 2. So which one would be easier? The first one. Because it's got a mechanical advantage of 3 to 1. It's going to be easier to lift something with that one. Because for every 1 pound I put in, I'm going to get 3 out. Number 10, what can be added to a machine to reduce friction? Well, that friction is always present. It's always a thing that holds us back. Well, that's why we add oil or grease to things, is to try and reduce the friction, which makes it so something is more efficient. I get more of my work out on the other end. I don't lose as much to friction, which produces heat. And that's why when you rub your hands get warm. It's because of friction. Number 11, if the mechanical advantage of an inclined plane equals 3, what is the weight of a box? It takes 100 newtons of force to pull it up a ramp. Ooh, that's a challenge, isn't it? Well, what it is then really it's, I'm only putting 100 newtons of force into it, and it's a mechanical advantage of 3. So really that box has a weight of 3 times 100. So that is 300 newtons. All right, so it's making it easier for me to push this 300 Newton box up this ramp because I'm only putting 100 newtons of force into it. 13, list or draw the 3 types of levers and label each with resistance, fulcrum, and effort. Remember the idea of a free answer. I'm going to hold these up here, and that is that, remember you put the word free, F-R-E, all right, and if the F is in the middle, then that's a first class lever. That would be like a seesaw. If the resistance is in the middle, that's a second class lever. That's like a wheelbarrow. And if the effort is in the middle, that's a third class lever. And that's kind of like a baseball bat, or what did I write down there? Or a hockey stick. Right? So remember, a free answer. And like going back to the first one, if I put fulcrum in the middle, then I put R and E on each end. It doesn't matter which end they go on, as long as the fulcrum is in the middle. So that's how you tell the difference on those. All right, that's 1 through 13. So now we go to the multiple choice questions. Question number 1, there are blank types of simple machines. The right answer is 6. 6 is the right answer. Number 2, which of these cannot be done by a machine? Well, it can't multiply energy. All right, energy can't be created, nor can it be destroyed. All we can do is change its form, that's all. But I can multiply force. I can change the direction of a force, right? But I can't multiply energy. Number 3, in an ideal machine, the work input is equal to the work output. So whatever work I put in, I'm going to get the same amount out. This would be the idea that there is no friction. Well, as we've talked about before, there's always friction present, so there is no such thing as an ideal machine. Number 4, the blank of a machine is the number of times it multiplies the effort force. That is mechanical advantage. Mechanical advantage is multiplying force. Number 5, to raise the resistance 4 meters, the effort rope of a fixed pulley must move 4 meters because they have the same it has a mechanical advantage of 1. All right, I'm going to stop right there, and we're going to go to part number 2. So I'm going to see you in a second.